Okay, so hopefully the video that was not made by me, but probably did a better job than I ever could, gave you a little insight into what a regression analysis is. And so what I want to show you now is how to implement a regression analysis, as well as graph the kind of best fit linear line representing a relationship between a independent or predictor variable and a dependent or response variable. And so to use this, we're going to use the car speed versus stopping distance data set. And I already kind of have our final goal represented right here. So here we've got stopping distance versus speed. You've already seen how to plot this as a scatter plot. Now we're just going to learn how to fit this line to represent the relationship between the speed at which a car is moving and its stopping distance. Here you can see the equation of the line, y equals 3.9 and some change times x, or the speed, so the predictor variable, minus 17.579, which is where the intercept on the y-axis would be if you kind of carry this line all the way to x equals 0. As well as the r squared value. Now again, the r squared is essentially the percentage of the y, or response variable, that you can infer being impacted by the x, or predictor variable. And so this is kind of, you could almost think of this as kind of being close to summary statistics or descriptive statistics in some way. We've fit a line here, but is that line statistically significant is a different question. Just like we could plot the means of different populations, we actually don't know whether those means are significantly different from one another. Much like we don't know just by looking at this if this line, the slope of this line, is significantly different than 0. And that's where a regression analysis comes in. So if you're on Mac, you can follow how to install the analysis tool pack, which is something we'll need for regression here in this video. I also have put a link if you're on Windows. So if you're on Mac, all you have to do is, when you have Excel open, go to Tools and go to Excel Add-ins. And it's as simple as checking this analysis tool pack. And you hit OK. Now, from here, if you kind of shift over to the Data tab, you're going to see this Data Analysis box. And that's what we're going to ultimately be using. So first, let's start with how to actually make this graph, and then we'll run the regression analysis. And so it's really as simple as what we did for a scatter plot. So we're going to highlight both of our columns of data, our x and our y values, and we're going to make a scatter plot. Again, remember, speed is the first column, and so speed is going to be our x variable, and then our second column is typically going to be treated as the y, or response variable. You could go and make all the axis titles and everything by going to this add chart element. I'm not going to rehash how to do all that again here, but what I will show you is how to add the trend lines and how to add the equation of the lines and all that. So what we're going to do is we're going to go to trend line and hit linear, and now we've got that. And if we go to more trend line options, here you can go ahead and also check set the intercept, or sorry, display the equation on the chart and display the r squared value on the chart. So that's how we ended up getting those kind of important pieces of information up there as well. Now I'm going to delete this one because I already have a nice labeled version of this. And now I'm going to show you how to actually implement a regression analysis in Excel, which is actually relatively straightforward. So once we have that analysis tool pack installed, we're going to go to Data. We're going to click Data Analysis. And this is a series of different formulas as well. It has some other t-tests and things you can run through there. But what you want to do is scroll down till you get to regression. And you're going to hit OK. And now you're going to get some places where you have to input some information. And so it wants to know the range of our y variable. Now again, remember, this is our dependent or response variable, which in this case is going to be stopping distance. So we'll click that little button, and all it wants us to do is click and drag over all of the data. Now notice, I did not select the actual column header. You don't have to do that. You can, however, if you want to. And so we'll do it both ways. That time I didn't select the column header. This time I will select the column header, and I will go ahead and select that. If you decide to do that, you're going to want to check the box Labels so that it knows that the first one is a label. Now we'll do the X range, which will be speed, which is the independent variable. or the predictor variable is kind of how it's referred to in regression analyses. And now all we need to do is tell it where we want the output for the analysis. It's going to kind of be a big box, so I tend to kind of put the upper left corner right there, and then it'll just fill in. And so if we hit OK, boom, we've got it. And so here is kind of all the stats associated with this line between these two variables. Some of these are more important than others for you to know, so I'll kind of highlight the big ones. Here we've got kind of the r squared. You don't need to worry about adjusted r squared value or anything like that right now. That's more if you're trying to do something more than 2 variables, if you've got like 6 predictor variables or 3 predictor variables. Here we're just doing 1 predictor and 1 response variable, and that's all we'll do in this class. So the r squared value, we'll go ahead and highlight that. That's an important one. That's the kind of the proportion of influence the predictor has on the response. But again, I mentioned that we actually need to know whether that's significantly different than no impact. And so what really influences our interpretation of that is down here under this regression line. This is kind of the stats for the regression analysis itself. And so this says significance here. This is actually our p-value. It's 1.4 times 10 to the negative 12th. So it's actually really, really, really small p-value, much less than 0.05, suggesting that there is really a proportion of variation of the dependent or response variable is explained by the predictor variable. If this was higher than 0.05, we'd say that there's really no evidence of a relationship. So this is where you're going to look to support whether there is kind of this linear relationship between the x and y variables. If you want to look a little further, there's actually a p-value associated with both parts of drawing this line, whether it's the y-intercept, that negative 17.5. Here you can see the coefficients. The intercept, the p-value for that is right here. And all that's saying is that our null would be that the intercept is equal to 0, and our alternative would be equal to non-zero. And so here we can see our p-value is less than 0.05, and so we can kind of accept our hypothesis, statistical hypothesis, that the intercept is different than 0. And the same can be said for this slope of speed. And so speed here is our x, or predictor variable, and here you can see that the slope of the line is 3.9 and some change times x, or speed. And here we can see that the p-value is also really quite small, suggesting that the slope is also non-zero, suggesting that there's a relationship. So these are kind of the 3 kind of pieces that you're going to want to look at in your regression analysis. Typically, when you're doing just one predictor variable, which is what we do in this class, it's sufficient just to look at the significance of the regression itself. When you've got multiple, if you've got speed and maybe type of tires and things like that, you can end up in situations where your regression is not significant, but some of the predictors are significant, and you can use that information to trim things out until you end up with just predictors that actually are informative enough to have a low p-value for your regression. Okay, and so that's really all there is to it, to running a regression in Excel.